Okay, in this section we're going to be going through 5C. So that's going to be the conversion of energy. So this section's fairly straightforward, but we're actually going to use it a lot. That's why it's a separate section. So the big idea here is that energy can be converted from one form to another. So again, just because energy exists in one state doesn't mean it couldn't be transferred to other states. For example, a light bulb is left on and becomes hot. This would be a transfer of energy, this right here. So you'd have a transfer of electrical energy to thermal energy. So again, you have a light bulb, light bulb giving off light. So when that actually happens, you're going to have some amount of heat being generated by that. So that means some of that electrical energy is gonna actually be in thermal energy if you leave it on for long enough. Another good example is a stick of dynamite exploding. So when a stick of dynamite explodes, I guess I'll draw it down here. So if you have a stick of dynamite, it explodes. What's happening is as it breaks in all those pieces, you're getting a conversion of energy. So originally it was mostly chemical potential energy when it's just sitting as a stick of dynamite. There's energy stored in the chemical bonds, and then once it explodes, you're actually getting that chemical potential energy, and it's being released in terms of kinetic energy because all those little particles are moving. Some of them really fast velocities. You're also releasing heat. So you're releasing heat. There's going to be some thermal energy. It's moving the particles are going to be moving very fast. You're going to get some kinetic energy. So that would be what happened. And so when we look at conversion of energy, it's helpful to think about energy transfer diagrams. So here's a good one below. So here's a good one right here. Energy transfer diagram. So again, this is for the example I just talked about. So the chemical potential energy in the dynamite is going to be converted to kinetic energy because the particles are moving. There's some amount of motion. And then thermal energy because it's giving off heat. So again, this is an energy transformation diagram. It's very basic. It's just showing the flow of energy, where it started and where that energy ultimately gets transferred into. And you're going to be seeing more of those later. And the last part is really just generalizing this a bit. So the last couple concepts, we're going to talk about a system. So a system is a group of objects. Well, it could just be one object, I guess, that's being looked at. So again, system could be, I don't know, maybe it's one object, maybe it's many objects, but it's whatever you're examining at the moment. So that would be your system. And important to keep in mind that energy can be transferred from one system to another. So again, you could have, for example, if you have like a coffee cup, say for coffee, it has thermal energy, and some of that thermal energy might actually flow out of the coffee and into the surrounding air. And in that case, you'd have a transfer of energy. So again, this is this is kind of a simpler unit, but again, just to summarize quickly, energy can be converted from one form to another. We use energy transformation diagrams to show this, and energy can be transferred from one system to another. Okay, that's about it for that. So now we're going to do an example problem. Sample problem. Yep, here we go. So for this, again, before I go through it, make sure you're attempting the problem first, right? You're not reading articles on Dig. You're not just waiting for me to stop talking so you can copy it down. Make sure you're attempting it first. Okay. So what we have here is it's asking you to diagram the transfer of energy. So the transfer of energy, or really the conversion of energy, same thing, for the following scenario. A ball is dropped and bounces off the ground to its original height. So before I do the energy transfer diagram, or energy conversion diagram, I'm going to draw out what's happening. So what we have is a ball. It is hitting the ground, moving at some velocity, and then it hits the ground and it actually squishes a little bit. Squishes. And then after that, it's going to be moving up with some velocity, and then it's going to eventually reach its original height. So that's the idea. And I'm going to put numbers on this just for clarity. So again, it starts, you drop it, then it starts moving, and eventually it's almost ready to hit the ground and starts moving pretty fast. And when it hits the ground, it's actually squished a little bit. It compressed. And then it bounces up off the ground, and then eventually it's going to bounce all the way up to its original height. So again, that's the idea of what's happening. Now would make sense to show what the diagram would look like. So at first, again, maybe you could argue other types of energies. I'm only going to show the major types of energies in the diagram. So what you would have is originally is mostly gravitational potential, right? Because it's held some height above the ground. So UG. So again, UG, gravitational potential. This would be in the first part 1. And then what's happening is as it's falling, that some of that energy is being converted to kinetic energy. And again, once it hits the ground, right as it's about to hit the ground, it's almost all kinetic, really. And then what happens is it bounces. So that kinetic energy that was gravitational potential is now being converted to elastic potential because it's being kind of squished and you're storing energy like that. So I'm going to write this UE. So U for the potential energy, E for elastic, right? So elastic potential energy as it squishes. And then what happens is it bounces up. So again, that elastic potential is being converted back to kinetic because it's moving, but it really hasn't got too far off the ground yet. So we go to kinetic. And then what would happen is ultimately it reaches its original height. And it's going back to gravitational potential because it's elevated off the ground. It's really not moving when it reaches its maximum height. And that would be the last part. Okay, so that's a pretty good example about what you're going to see in the future. Again, make sure everything is, you have the solution, you have your notes annotated, and that's it for 5C.